add those data points on your data. Okay, and Saib used to do campaigning and the strategy for PepsiCo. Okay, so he is a ex PepsiCo candidate, and he was using the statistical imputation in his sales, marketing, projection, and all mean, mode, median. He was telling me yesterday before you guys joined call. So me and he were just discussing. Okay, but see, Saib, this is a good opportunity. If you have anything that you want to take on Thursday tomorrow, one small session kind of thing, you are welcome. Okay, or not this week, at least for next week. Okay, just prepare 3 slides. Okay, strategy. Okay, sales, whatever. Okay, so it is a good learning for others also. Okay, so let's get back to is my statistics over here. Okay, so I think yesterday a lot of people were missing. So we will start the session with statistics basics. Okay, and then what we'll do is we'll do some hands-on. Okay, so yesterday we did some basics. We'll do some more basics today. Okay, to get that feel of how to use the statistics with your data. Okay, you can start the recording, Sir. Okay, you can mention statistics 1 for the last video and this one statistics 2. Okay? Or you make version 1 or version 2, something whatever you want to keep a meaningful name for our videos, and so that they can refer which one is 1 and which one is part. So those who missed out, please go through this. Okay, Vishal, whatever the data you have with ticketing tool AWise, right? You have to apply all these principles. Okay, and then I'll show you what this data is talking about. Okay, where you have to work on. Okay, so let's get so statistics. Okay, we'll just go with the definition. So like I said, statistics. What is statistics is simple: collecting, organizing, analyzing, and interpreting. Okay, we do this in a daily. Okay, if you are buying a house, what you do is you'll first collect the information about house, which area, price, bedrooms, uh, builder, right? You do that, and then you will organize out of 20 list of house. What you'll do is you will filter top 5. Okay, top 5, top 10 based on your ratings, based on your friend or feedback. Okay, maybe some of your friends might have taken a flat there and they'll give their feedback. Okay, so this is good, then the quality is good, water is good, spacious, parking is good, and all that, and then you will analyze. Okay, analyze. How do you do? You have to finally go there and you will analyze. Okay, similarly, when you get a data, you will organize that properly and then you'll analyze, and then finally you'll do the interpretation to make a informed decision. Okay, so what does statistics help with? Understanding the data patterns. Okay, patterns is if it is sale data, how your patterns is going up and down. Okay, like a wave, sea wave. Okay, and predictions. Okay, prediction is very important. See, the ultimate use of statistics is when you make a prediction based on your data. After you're doing all these 4 um, uh, steps: collecting, organizing, analyzing, and interpreting, you'll do prediction and decision making or using some of the statistical methods like probability and hypothesis testing. Okay, we'll have all these things in the upcoming classes. I'll do that one by one. I'm going very slow pace. Okay, to help you understand, because you have to apply this. Just listening will not help you out, guys. Okay, you have to do hands on. You have to make your hands dirty. Okay, with practice and all that. You let it be. If you get error in the next class, show me the error. I'll fix it. Okay, this is how you're gonna learn. So in statistics, there are 2 branches: descriptive, inferential. Okay, and there is one more called prescriptive. Recently, it has come. Okay, prescriptive. Prescriptive is like just like a doctor. You have a fever, you go to doctor, and he'll give the prescription. Take this. He don't know whether you will get cured or not. After 3 days, he'll ask you to visit again if it is not cured. Right? You might have seen in the your prescription at the top. He'll say 3 days validity, 5 days validity, and all. Right? What is that called? Prescriptive. But prescriptive, see, in statistics and all, when you are playing with data, you cannot give a prescriptive option here. Okay, you either you have to be a descriptive or inferential. Okay, so what is descriptive? Okay, descriptive does the summarization of data, okay, in a meaningful information. And what are the techniques that you're going to use? M cube, which is mean, median, mode. Okay, and the second one is variance, standard deviation. Okay. And the last one is range, percentile, quartiles. We have done yesterday, but I'll just go through it again just to refresh, and then we'll catch up with the other topics today. And next branch of statistics is inferential. What is inferential? See, when you have a data, when you organize your data, you collect the data, organize, analyze, and interpret. So final is what? You have to do the prediction, right? Whether with the weather forecast data for 10 years, you will predict whether this time whether we'll get any tsunami attack or not. Okay, in Chennai or Vizag or wherever, see, coastal areas. Okay, so that is what you have to do, the prediction. Just doing the analysis will not work out. You need to do some inferential. Okay, and like I said, there is another branch which is called prescriptive. Prescriptive is what? Same thing I just gave you example is, when you have a fever, you go to doctor, he'll write tablet 1, tablet 2, syrup 1, syrup 2. Okay, and he'll say visit after 5 days if it is not cured. So what is that? He's just give a prescription. He don't know whether you'll get cured or not. Okay, there might be a chance you get cured. And how does he give the prescription? Based on his experience. Okay, maybe there are some other patients who have come with the similar symptoms, and he has prescribed a similar tablets and medicine to him. Okay, so that is called prescriptive. Okay, but prescriptive, we don't use it as often. Okay, so definitely we have the descriptive and inferential is what we're going to use. In inferential, what are the statistical methods we have? Hypothesis, confidence interval, CI we call this confidence intervals. Okay, correlation. Okay, so correlation and regression. Regression I showed you in a scatter plot, right? If a line is like straight from the 0 point x and y, okay, and if your data are there near to that line, okay, that is called regression. We'll have all these things in the machine learning. Okay, we're going to do all this model understanding in our machine learning. Okay, so first we're going to do Python basics, then pandas, and then EDA. Okay, exploratory data analysis. Next topic is that, and after that we're going to do some SQL study. Okay, SQL. And then after the SQL is done, machine learning. Why machine learning we are going after that is because you have to learn ingesting data from backends. Okay, your database. Okay, it could be anywhere from a browser if you want to scrape some data. Okay, and convert that data into a data frame like a tabular format with columns and rows. You need to learn all those techniques. Okay, this is what a data scientist does. Data engineer. Okay, scraping data, connection, connecting with backend, ingesting data. Okay, and then he will clean the data. Then next step is he will transform the data, and then finally he will visualize the data. And last step is inferential statistics or descriptive statistics he will use and take a decision making. Okay, so this is yesterday's class, guys. Those who missed out, I'm just repeating. Okay, so this is a sample data I am creating here. This is a variable called population. I'm using here NumPy. Okay, and I'm using np.arrange. Okay, from 1 to 100. So 1 to 100 sample number I'm taking. Okay, and then I'm taking another one called sample. Okay, yesterday. Sample, 1 minute. Okay, that was a PDF, guys. Okay, yesterday I was showing you, right, sample and population. What is population? Population is the entire data. For example, last year tickets. Okay, support folks, last year tickets. Okay, so from Jan to December, that is your population, entire population. Okay, I'm taking a sample. Okay, now how do you take a sample? I can take first quarter, second quarter, or half yearly, right? So Jan, Feb, March. That is a part of data that I'm taking from the entire population. Okay. Now here, what is my entire population? 1 to 100 numbers. Okay. And what is sample? I'm taking population of 10 from this sample, any sample data. Okay. And then I'm gonna run through the mean and mean on population and mean on sample. Okay. So I'll run through and then I'll explain. Okay. 1 minute. I need to clear output of all cells. Yeah. So first one, second one, you can see the population mean is 50.5. Okay, this entire thing. Okay, and now what is the sample? Sample mean is just 10 entries I'm taking from the 1 to 100, and I am taking the mean, so which is 38.3, and this changes. Okay, so this is random. You can see random means it keeps on changing. If I run this again, okay, now you see 53. Okay, now if I run again, if I run this again, 65. Okay, it keeps on changing. It picks up those numbers automatically. Sample of 10 from this 1 to 100, any number it will take. Okay, so you keep on changing. So this is one way, good way to learn with a NumPy library for numbers, for testing, for practicing and all. Okay. Now, talking about measure of central tendency. Okay, so what is measure of central tendency? Okay, so measure of central tendency includes mean, mode, median. Okay, mean is the average, median is mid value, and mode is most frequent value in our data set. Okay, why these are important is, see, if you have a repeated value, okay, say for example you have a roll number in school. Okay, so same employee 2 times or 3 times, if his id is coming there, what happens is obviously it will give a wrong inference, right? So you need to use this techniques, statistical techniques, to identify those patterns: mean, median, mode. Okay, so here what I'm using is import statistics as stats. Okay, this is a pseudonym, and then I'm using import pandas as PD. Okay, and I took here a sample data. Okay, a list, something, some sample. Yesterday I typed it sample, I took something and I'm storing it in data. Okay, now what I'm doing is I'm converting this data, entire data, into data frame. How do you do that? I'm going to use pd.data frame. Okay, pandas has a function called data frame, convert that data. Okay, so pd.data frame, I'm passing out here the data variable that I'm storing all this. Okay, and then again I'm storing it, the value data frame, in df. Okay, so if I say df dot head, okay, now you see, okay, it is in the data frame. Okay, so these numbers, whatever you see, you'll see in a row only. Okay, but I'm seeing only 5 because head gives you only the 5 top row. Okay, if you say tail, last 5 rows. Okay, but what you see here is your indexing. Okay, like I said, Python starts your indexing from 0. Okay, now I will use I'll use something called describe method. Okay, what describe method does is it will give you the statistical imputation of mean, mode, median, min, max. Okay, and quartile. Okay, so all those things from this number. Okay, I'll run this and then I'll explain. Okay, so this is the view. Without dot t, you will get view something like this. If you put dot T, which is transpose. Okay, so right now you see it is a vertical. Now you will get a horizontal. Same thing. You see all this at the top. Nothing, no difference. Okay, so something like this. Okay, so you can use both. So number will be same. Only thing is the view area which was earlier like a horizontal, sorry, vertical. Now it is in horizontal. Okay, so count. Okay, how many count are there in this number? 18. If you count, you'll get 18 numbers. Okay, what is the mean? Okay, so summing up all this and divided by 18, you get this 20.66. Okay, and what is the standard deviation? 24. Okay, what is standard deviation? It's a difference from your variance. Okay, so in Monday's class, I think last week class, I was explaining about this basics, but when we do some more practice with the sample data, right, I'll explain, you will understand automatically. Okay, standard deviation. And what is the minimum number here? It shows 3. Your minimum number is 3. Okay, and maximum number is I can see 99. So maximum number is 99. Okay, the last one. And you see 25% bucket. Okay, what are the value that falls under 25% bucket here from this number is up to 7. Okay, 50% 8.5. Okay, 8.5 is what it shows, and 75% till 33.5%, starting from there, all that number after 33.5 and above, which is up to 99, falls under 75 percentage. Okay, this is very important when you have a sales data uh, or some relevant data like continuous data. Okay, continuous data, you can project that into the describe method and you can get this properly. Okay, now we will use the statistics function. Okay, this one. Okay, we have you can do this statistics imputation with statistics library also. Okay, so we have in pandas we have something called describe that does the same thing, or you can use the statistics library to make use of that. Okay, so here what I'm doing is I have a quotation here. This is just for displaying a message here bottom, and then stats, the very stats, my this one pseudonym stats dot mean function is there, and I'm passing out this data. Okay, same data, same thing I'm doing for mean, median, and mode. Okay, let me run this and then I'll explain. So what is the mean here? 20.6. Okay, so here you can see 20.6, same thing. What is my median? 8.5. Okay, now you have to relate here 50%. Okay, so 8.5. Okay, and what is my repeated value in this from this number? Okay, you see, if you see 7 7 7 7, 4 times it is repeated, so mode means repeated value. Okay, which is 7. Clear guys till now? Okay, now
Yes, sir.
we will talk about measure of dispersion. Okay, now what do you mean by dispersion? Dispersion means how your data is spread. Okay, so when you have data, sales data, then height data, right? uh, for example, take your team. Okay, your team has 25 members. Okay, and you capture their age and height. Okay, so when you capture and when you put in Excel, you want to see how their data is spread out. Okay, so do you see any anomaly in that? Okay, so the dispersion method will help you to see how your data is spread out. Okay, and it gives you a lot of inference guys. Okay, if you have something called skewness. Okay, skewness will start uh, tomorrow, or tomorrow is Wednesday, right? Yeah, tomorrow or day after tomorrow. Okay, so we'll have understanding of skewness. Okay, so what are the methods that are available from statistics? Are range, variance is the difference between, if you get a mean. Okay, for example, what is my mean here? 20. Okay, and I want to see the other values. Okay, this 5 7 3 7 9, from this average mean how far is this? Okay, it should be I mean it should be close enough for from 20. Okay, if it is too far, okay, for example, what if I put here comma 2000? Okay, now if I ask you how far is 2000 value from this? Very far. So this is an outlier. Okay, we need to immediately remove this. Okay, So I'll run this. Okay, now you see mean has changed to 124. Okay, but when you present this data in visualization in the form of skewness, right? uh, the bell curve, yesterday I was showing you bell curve, right? So if you see, if you will find a right skew. Right skew means you have a outliers. Okay, serious outliers are there. You need to clean your data fast. So it could be a typo mistake. Instead of 20 I type 2000. Okay, so it cannot be. See, if you see, all these numbers are near to each other, but if you add something very number which is far away, okay, when the decision when you take, right, it will never work out. Okay, so it might fail. Okay, I'll put it back, and this one also I'll put it. So coming back to range, what is the range? Okay, so range means the whatever the values we have here. Okay, so I'll just copy this. So same data we are using here also. Okay, I'll use data 1. I'll put this sample in hash. Okay, now whatever the data here I'm playing is data 1. Okay, same thing here. So I have this data. I'll run this first. Okay, now what is a range? What is the formula for range? Range is maximum data. Okay, in this list, what is the maximum? 99. Okay, and minus minimum. What is the minimum here? I think 3. Okay, when you minus 99 minus 3, okay, 6. 96 is your range. Okay, now how you will interpret that with real time? Okay, those we'll see in data when we get some sales data, then sports data, healthcare data, right? I'll make you help you understand how it will range. What does it help you to interpret? Okay, and how do you get the variance? We are using here NP. NP, what is NP? NumPy. Okay, NumPy NumPy feature we are using dot var is for variance, and you are pass on this data, entire data. Okay, and what is the standard deviation? NP dot std. Okay, simple. See, actually the formula, if you see, standard deviation is very big. Okay, so when you do it in paper for this data, it will take at least 4 5 hours. Okay, for the simple data. Okay, but here with a one command, one line command, np dot std, and you're passing your data variable, which is your this numbers. Okay, I'll execute this, and then we'll see the result. Okay, so like I said, range is 96. 99 minus 3, 96. Variance is 550. Okay, the from your this thing. Okay, and the standard deviation is 23. Okay, which is okay. Okay, now what we'll do is we'll play around with some more data. So I have already created all these things in a what do you called in a notepad. Okay, again it will take a lot of time for me to type and do this, but you know all this thing. Dictionary, I'm using a dictionary. Whenever you see curly braces here, it's a dictionary, it's a key value. Okay, so I'll run this, and you'll see first we are creating a data frame. Okay, so this is the numbers. Okay, in math some numbers are there. Okay, science some, English some, and whatever you see here, it's called nan, means not a number, so it's an empty row. Okay, so Python will treat that as nan. You will definitely get this type of data when you're working real time. Okay, now what we're going to do is we're going to do the mean, median, and sum. Okay, for this data, so I'll just put it here, code markdown. Okay, for this data we'll do the mean, mode, median, and sum. Okay, so how do we do that? So sum is simple, df dot mean. So what is my data here? Df. Okay, so print statement I'm using mean, df dot mean, df dot median, df dot sum. Sum means the sum of all these numbers. I'll run this. Okay, now you see, mean for maths is, see, we have 3 columns here, 1 2 3. So it has done individual for math, science, and English. So what is the average? 81%. Okay, for science 83.50. Okay, average. And what is English? 80.25. Okay, now data type is float. Okay, these are all float. Why? Because point 0, you can see one decimal point here, right? Same thing, median. For maths, what is the mid value? Okay, mid value is 85, science is 89, and English is 79. Okay, the mid values. It does automatic, it doesn't treat all this nan and all. Okay, but going forward, we'll see how to treat this, 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 this. Okay, which is very important when I ask you to take a decision on this. Okay, because already you have a missing value. In English, in maths, you have one, in science 2, and English 2. So obviously when you're taking a decision, giving your decision making, right, you're making a wrong decision because you have not treated your data here. You need to treat all your data clearly, equally here, and then you have to do. We have one lesson why we have to treat our data. Okay, so right now we are into basics. So let's focus here. Median. Okay, median we are done. Next one is sum. What is the sum? 406. Adding all these things. Okay, 334, 321. Okay, so this is one, and min max. Okay, you can do different ways, guys. I'm telling you, right? Okay, df dot min, df dot max. Okay, so what it will do is for maths, what is the minimum and max? What is minimum and max for science and English? It will give you. Okay, so you can see three columns are there. 55 is the minimum, and maximum is 98, 96, 95. Okay, sometimes you want to see the top 5 sales predictors from the sales data, so you will use this min max. So these are very useful. Even in SQL you will have to use min max. Okay, now we'll look at the standard deviation. Okay, now what does the standard deviation do here? Okay, it computes the spread data. Okay, it computes the spread of data. What is the formula? You can say df dot std. Print df dot std. Okay, now you see what is the standard deviation for math is 16, science is 16, and English is 12. Okay, so what is these numbers? Standard deviation. Okay, how do you get arrive at standard deviation? So how do you get is a variance square. Whatever the variance you are getting, the square of that value will give you this. Okay, now we have already done variance. 1 minute, this one. Okay, so I'll just take this entire thing. Okay, and here what is the data point here where we are storing df? So I'll say inside df. Okay, now see the variance here. Mathematics is 214, 210, and 100, 108. Okay, so you can ignore. See, you sometimes you'll get this. This is not a error. This is called warning, future warning. What that means is it means that some of the features that you're using has been depreciated with the next version of Python. Okay, so this variance np dot variance or df dot or pd dot variance, I don't know pd dot variance is there or not. Pd dot variance, it's not there. Okay, module pandas has no attribute called var, so it is not there. It is np. NumPy has that feature. Okay, okay, so this is the variance. Okay, and then we'll do the statistical imputation for that data. Okay, which is describe method. Okay, so count is 5 entries are there. If you see from data, how many counts? 1 2 3 4 5. Okay, 1 2 3 4. English 1 2 3 4. So except maths, science, and English has 4 entries. That's what it's showing. Count is equal to 5, 4, 4. Mean, what is the average? 81, 83, 80. Okay. Now, if you do the same thing with dot tree transpose, you'll get a horizontal view. Okay. That's the only difference. Whichever you like it, guys, you can do it. With T transpose, it's called transpose. You can use this or that way. Okay. Now here you have a subheading. This is the count. This is the mean. This is standard deviation. What we got here, 16, 16, 12, and minimum. Okay. At 25th percentile bucket, what are the data points that are falling is 78, 85, and 90. Okay. 75 percentile. Okay. 90, 85, 70. So this is how, and what is the min and max? Okay, min is here and max. If you want to find out the minimum marks student scored, what you will use? This one, min function, and maximum this one. Okay, top 5 you can use the head. Okay, with max. So there are different ways to get the data. Okay, that will make your life easy. Okay, and then I can run one more. Okay, mean by student row. DF axis 1 skip NA is equal to NA means not applicable. Okay, I'll run this. Okay, so wherever you see this missing value, right? NA, 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 NA. Okay, that I am removing using this function called skip NA is equal to true. Okay, so you see now it is all clubbed in one group. Okay, and after this is done, if I want to do a plotting, okay, only for maths. Okay, we learned about plotting, right? Seaborn and matplotlib. So I'm using matplotlib.pyplot as plt. So here I'm taking a column called maths only. Okay, maths column. Okay, and dot I'm telling Python to plot histogram. Okay, with a bin of 10 and title distribution of math score plot dot show. Okay, 3 lines code. Okay, you can see here. Okay, so it almost looks like same. Okay, and histograms are ideal for seeing data spread and outliers. Okay, you see this is also same up to 100. This is also same. This is also same. Okay, math. So you don't see any changes here. Okay, and 70% something is missing because the data is NA something is there, right? 3 entry or 2 entry. So that is the reason we have see empty bars here. Clear, guys, so far? Okay.
Yes, sir.
Okay, 1 minute. So tells I have to cover in basics. Main mode, median mode is done. Okay, dispersion, range, variance, standard deviation. Okay, see, I've already shared this also. I don't know whether I've shared this, but Saib, can you share it with everybody later on? You have to click on share and then you have to share with their email address. Last time they have already shared their email address, so you can share it with them. This entire PPT. Okay, range is the difference between min and max values. Variance is the average of the square difference from the mean. Okay, and standard deviation, the square root of variance. Like I said, square root of whatever the value you get in variance, when you square root it, you get your standard deviation, providing a measure of spread in the original units of the data. Say, for example, this is your data points, okay? And when you do a variance and standard deviation, this will look something like this, okay? Now, this you see this height and this height, okay? That's reduced, okay? So this is where original data and after processing the data you'll get something, but you see the data is like this bar that you see here, it is like a bell curve. Okay, whatever this tail you see and this tail, it never touches this x value, sorry, x axis. Okay, here it is showing in pictorial, but it never touches. It just goes above that. So that means you should not have a negative data. If you show negative data, it will go in -1, -2, -3. Okay, this is 0. This is our positive. If you go beyond, okay, 20, -10, -20, -30, it will go. Okay. So but as per practice, standard deviation is the square root of variance providing measure. So these are some basics, and coming back to this, okay, you just forget about all these things. I just showed one example. Okay, so you just forget about the same thing. If you copy, just copy. Okay, here instead of maths, what is the second column we have? English, right? Science and English. I'll take the science column here. I'll replace this with science, and here also I'll say science course. Okay, so the heading important. Okay, now you see this. How different is this? Okay, so most of your data fall in under 85, 90, and 95 because you have some missing data there, right? If you recall. Okay, I'll do the same thing for English. Okay, now you see how the data is coming. So you have 70, sorry, 68. So let me check, go back. What is the minimum value for English? Minimum value is 67. You see here, 67, 55, 67. Okay, 70. Then the next bin is, this is missing value. This is missing value. There are two missing values here. Here you have a lot of missing value from 65 to till 80, 85. You have a lot of missing values. Okay, and missing values make some added value. Okay, when you are doing some analysis, right? So if you have a missing value, first I mean job is to treat those missing values. Okay. This is one, and one more I want to teach. Okay, coefficient, right? Coefficient. Give me a minute. Uh, okay. Okay, so this is simple random I'm using, import random. Okay, random, what this is one of the library where you can do some experiment. Okay, so random has this capability. You can do with NumPy also. I'm using random. Is there are different libraries that are available in Python. You can use make of all those libraries. Okay, random. I'm using a variable called trial, and I'm using something called 1,000. Okay, 1,000 times I want to do heads and tails. Okay, now heads is equal to sum of 1 for in range. I'm using for loop here, for in range trials. Okay, this one trial. Okay, this value trial if random dot choice is equal to heads, okay, or comma t, then we'll say it is first one is head. Okay, print estimated probability of heads. Okay, heads and trial. And how do you get this? Heads divided by trial. Okay, so this is a formula for probability, estimated probability of heads. Okay, so what that it shows is 50.51 is 51%. There is a chance that you will get a head. Okay, 51 chance. There is a simple. If I run again, you will see change again. Okay, because like I said, random number always keeps on changing. So 5, 50, 53.53 is chances that you will get heads. Okay, or else you can say tails. Okay, this is a simple example. Okay, instead of this, I'll say 10. Okay, trial of 10. 10 times I will flip a coin in the air, and I want to guess what is the probability that I'll get heads. How many times if I do spin the coin, how many times I can get. Okay, so you will use probability. This is a simple uh, function. See, 3 times, 0.3%. There is a probability out of 10 times, 3 times there is a probability that you'll get a heads. Simple. Okay, so these are all functions, right? Okay, very simple. I'm gonna save all these things and then I'll share it with you guys. Okay, so these are very important. Okay, so another example that I can give is I have already written this. Okay, a dice, everybody knows, right? Dice. Okay, that we play in Ludo, Guido and all, right? Dice. Okay, dice is rolled 6,000 times. Okay, and you have to stimulate the experiment and calculate the probability of each phase. How many phases are there? Six, right? One, two, three, four, and then sidewise two times. Okay, six phases are 1 to 6. So you have to calculate the probability. What is the in 6,000 times? What are the probability of all these phases? Okay, I'll just mark down. I'll put it in proper column. Okay, now solution I've already written. Okay, I'm using random again. I'm using collections from counter. Okay, why do I need counter? Because I have a 6,000 time, right? I have to count that. So for 1, 2, 3, likewise 100, then 1,000, then 1,001, 1,002, 1,003, 1,004, like counter. I'm using counter here. Collection, import counter. Okay, there is a library called collections. Okay, it has a library called counter. I'm using this counter, and trials I have taken 6,000 here. Okay, and rolls is random dot rand int 1 is to 6, because in those dices you have 6 faces, right? 1 comma 6. Okay, for in range trials is this base number 6,000 times it will try. Okay, and it will count rolls. Okay, how many rolls it is doing randomly. Okay, and here I'm using for loop here for face in range, for face in range. Okay, 1 comma 7, and probability of face, this is a message that it's gonna show, and it will count divided this face, whatever the you get here, face divided by trials. Okay, so this is your trials roll. First I'll run it and then I'll show you. Okay, so what it says is first time that there is a probability of 16, 0.16 is 16%. Okay, of getting number one dice. Okay, and second probability of 2 is 0.16. Okay, third is also 6. Okay, 4 is 6. Fifth, 5 is 17% is there more. Okay, and the other one is 60. Okay, so this also you can do a guesswork. Okay, now you see 15%. It keeps on changing random. This variable that you see library, it keeps on changing that number. Okay, what if I take only 6, trial of 6? Okay, so 0.33% says dice of 1 with a dot 1, right? There is a chance 33% says probability of 1. Okay, 2 no, 0, third 0.5, then 4 0.1, 1 6 16% probability is there, you might get dice of 4. Okay, 5 dice of 5 is 0 and 6. Okay, so these are all very good practice that you can do here, right? So you have to just go through that theory or whatever the classes you have missed. Okay, and then you can just change the value and do it. Okay, and why I am using 1 to 7 is, the indexing starts from 0, right? So 0 to 6 is what you get, 6 values, 1 to 6 dices. Okay, what is the time? 27. Okay, we'll do one more last, which is correlation. Okay, so I will do one more example, which is called uh, okay, find the correlation between study hours and exam scores. Okay, so there is a data where we have a study hours, the student data. Okay, number of hours is studying and exam scores. Okay, it's a simple data. So study hours is equal to 2, 3, 5, 6, 8. Okay, these are study hours. 2 hours, 3 hours, 5, 6, 8. And likewise, you can see the numbers are improving here: 81, 88, 92, 95, 100. Okay, just a sample number. So not necessary that 8 hours you are studying and you score 100. Okay, there are chances it might be less than or above 50. Okay, so this is just a sample for our understanding correlation. Okay, now this is our data. Now we'll do the correlation. Okay, how do we do the correlation? Okay, we will use something called numpy. Okay, so I'll say import numpy as np. Okay, np, and then I'll say print. I'll give the station correlation. Okay, then I'll put comma, and then I have to use np dot co correlation coefficient. Yeah, this one. Okay, so see, this is one line code only you have to write. Okay, you don't have to do the calculation. If you see the correlation standard deviation in Google, it's a lengthy task. Standard deviation formula. Okay, so I'll take the images. Okay, so you see here there is a standard deviation formula. Okay, root of sigma x minus mean square root by n minus 1. This is what you have a data and you have to do. In Python and all, you are just writing mean or std function, and you are able to satisfy that, right? So if you do it practically, it will be very tedious for you. Okay, now here I want to do correlation of what? I want to do study hour comma scores. These two values. Okay, I have these two numbers. Okay, I'm doing a correlation between this and two, and it will give me the coefficient value whether this one will work or not. Okay, and then we have to pass numbers from 0 to 1. Okay, square bracket 0 is comma 1. Okay, so I'll run this. Okay, now you see what is the correlation value I got? 97%. 0.97 is 97 of percent says whenever you increase your study hour, there is a chance of better getting a score. This is how you can use. Okay, now you have a marketing data, okay, and sales output, okay, sales, and you want to see if you spend more on your marketing, right, then there is a correlation will show. We're going to do all these things one by one. Okay, so this helps. Okay, so you can, by seeing this number, you can easily come to conclusion, yes, this is true. So 97% of correlation data, it is giving that positive. If you increase your this thing study R, then there is a chance of getting good score. This is just an example. Okay, so we are on top of the hour. I'll close this session 9:32. Okay, so tomorrow, Saib, you can stop the recording. Okay, and you can share it as statistics 3 or whatever. Okay, so check the heading and see. So this, see, data, we're gonna get some data sales. We're gonna do a lot of